Welcome to You Got Hope Chemistry. I'm Hope, and you're about to learn some chemistry. Okay, in today's lesson, we're going to look at mass stoichiometry and mole ratios. So mass stoichiometry is essentially chemical mathematics, and it's how we can relate one compound to another compound. And it's all based on coefficients. So for instance, looking at this chemical reaction here, we have a series of mole ratios, and I'm going to add a couple numbers in. There is a 1 here, and there is a 1 there. And although we call this a mole ratio, you can really just call them particles as well. So for instance, it would take 1 particle of CS2 to react with 4 particles of H2. If I had that ratio, it would produce 1 particle of CH4 and 2 particles of H2S. But if I have a particle or a mole, it's really the same thing. It's just a larger amount. I mean, 1 mole to 4 moles is the same thing as 1 particle to 4 particles in terms of a ratio. They mean the same thing. It's just a lot larger of a number or a lot smaller of a number. So I want to simplify this for you a little bit using very easy numbers to understand. So if I know it takes 1 molecule of this to react with 4 molecules of this, and I propose the question, well, what if I had 2 moles of CS2? I mean, how many moles of H2 would you need to react with it? Well, our brains can comprehend that very easily. I know a 1 to 4 ratio is really the same as a 2 to 8 ratio. No problem. Easy. That's just stoichiometry. That is the simplest way to do stoichiometry. What becomes harder is if I said something like this. Well, what if you had 0.066, I don't even know, let's say 68 moles of CS2? It would be harder for you just in your brain to go, what's 4 times that amount, to come up with the number of moles here. It seems a little bit more difficult, but that's all we're really doing. When I wanted to go from 2 to 8, I really just said this is a 1 to 4 ratio. I'm multiplying by 4. When you see 0.068, you might not see that connection that, hey, all I'm really doing is multiplying this by 4, because that's all you would have to do. You'd really just have to multiply that by 4, and you would know the number of moles that you would need to react with it. So what a mole ratio is just a comparison in fraction form of one species in a chemical reaction to another species in a chemical reaction. So I'm just going to erase this. And we're going to start with what are the possible mole ratios for this chemical reaction. And I'm going to tell you right now there's actually 12 ratios of moles, because there's 12 different ways we can compare substances in that chemical reaction. So I'm going to be writing right across this whole line, and I'm going to take up a lot of space, so I'm going to write quite small. Here's our first comparison. I could compare CS2 to H2, or I can compare CS2 to CH4, or I can compare CS2 to H2S. There's my first 3 ratios. So I'm going to do that. So what I would say is for every 1 mole of CS2, it would need to react with 4 moles of H2. And I'm just getting that from the coefficients. Now, I could also say for every 1 mole of CS2, I need to react that with 1 mole of CH4. Or I could say for every 1 mole of CS2, it will produce 2 moles of H2S. So there's my first 3 out of the 12 ratios. Now the next thing I could do is I can compare H2 to the other 3 species. So I could compare H2 to CS2, H2 to CH4, or H2 to H2S. Now, if you're thinking, Well, I've already compared CS2 to H2. It's the exact same thing. Let's write down what the ratio looks like. The ratio would be, I need 4 moles of H2 to react with 1 mole of CS2. Now, 4 over 1 is not the same as 1 over 4. That's a quarter. This is 4. If you think about that in terms of money, what would you rather have, a quarter or $4? There's a massive difference. That comparison is different. One is 4 over 1 and one is 1 over 4. So there are all of these different comparisons we have to do. So let's keep going. So I have 4 moles of H2 would produce 1 mole of CH4. I would also have 4 moles of H2 would produce 2 moles of H2S. Now, if you're wondering, do I really have to write these subscripts under here? The answer is absolutely, because we have to cancel out units, and it's not just canceling out moles, but moles of a specific substance. You actually need to have a subscript of what substance it is. All right, we're halfway there. So I could also compare CH4 to CS2, CH4 to H2, or CH4 to H2S. So the first one would be, for every 1 mole of CH4 produced, it would require 1 mole of CS2. Or, for every 1 mole of CH4, it would require 4 moles of H2. Or, for every 1 mole of CH4 produced, it would also produce 2 moles of H2S. Okay. I've got one last set of 3 to do using H2S, and I'm just going to do it down here because I'm running out of space. So I can compare H2S to CS2, I can compare it to H2, or I can compare it to CH4. So let's do that. For every 2 moles of H2S produced, it would require 1 mole of CS2 to react. For every 4 moles of for every 2 moles of H2S, it would require 4 moles of H2. And for every 2 moles of H2S, it would also produce 1 mole of CH4. So from a given question like this, I could literally ask hundreds of different questions using different amounts, using different mole ratios. So that's what a mole ratio is. A ratio is a fraction, and these are fractions using the coefficients, which will allow you to compare amounts of substances in a chemical reaction. Every stoichiometric calculation must include at least 1 mole ratio. So let's give a question a try here, and I'll guide you through the first couple, and then I'll give you opportunities to try questions on your own. So our first question here says, how many moles of CS2 gas are needed to form 5.6 moles of H2S? So this question is only comparing 2 substances, CS2 and H2S. So we're going to need a mole ratio for CS2 and H2S, but we have to figure out which one of those 2 are going to go on top of the mole ratio in our calculation. Now, we always have to start with the number we're given because we have nothing else really to work with other than the coefficients. So I'm going to start with the value I've been given, 5.6 moles of H2S. Then I'm going to write a fraction, and then I want to get whatever I'm solving for on top of the next part of the fraction. So what I'm solving for is moles of CS2. So I'm going to put that up here, moles of CS2. Now, whatever I want to get rid of has to go on the bottom of the fraction. So since I'm starting with H2S, I want to put moles of H2S on the bottom so that unit cancels. Now, whenever you have moles over moles, this is called a mole ratio. And the numbers that go in these spots come from your balanced chemical reaction. So if your chemical reaction isn't balanced properly, you can never get this question correct. So I'm going to go back to my chemical reaction. The coefficient on CS2 is 1. The coefficient on H2S is 2. So in order to calculate this, I would put everything in the numerator in one set of brackets. I would hit multiply. Then I put all of the denominator in brackets and hit equals. Now if you're saying, I get it, this is 5.6 times 1/2. Yes, this is a very easy question. There's only one fraction. By the time we get to the end of Math Stoic, you will have 3 fractions and you will be canceling out several different units, and it gets much more complicated. So what I'm trying to do is to train you to follow a set of procedure that will work no matter how easy or how hard the question gets. So please, we're going to get into a habit of putting the numerator in one set of brackets, hit divide, my apologies, everything on the denominator, and hit equals. And this would simply be 0.28 moles of CS2, because the unit of moles of H2S is going to cancel out with the unit of moles of H2S. As kind of a side note, just to give you a perspective, if you've taken something like physics and you were just simply doing a question like, oh, I want to know the amount of time something takes to go when it's going a certain speed. So for instance, let's say I went 5 meters and I wanted to know how long that would take if I was going 10 meters per second. I don't have to use an equation. I can simply use a fraction. I could say something like, for every 1 second, I travel 5 meters. That's 5 meters per second. And I'm traveling 10 meters. There's 2 parts to this. I have to cancel out the unit to get seconds. Meters would cancel. And then I would have a unit of seconds. And so this would be 2 seconds. 10 divided by 5 would be 2 seconds. We're doing the exact same thing. We're just using chemical units rather than physics units. All right, let's try one more, and then I will get you to do one on your own. So reading the next question, it says, how many moles of H2 are required to react completely with 2.97 moles of CS2? Now, following the rules, I have to start with the number I'm given. The number I'm given is 2.97 moles, and then I subscript what substance that is, CS2. Whatever unit I want needs to go on the top of the next fraction, which is moles of H2. That's my goal. Whatever unit I want to get rid of has to go on the bottom of the next fraction. So that would be moles of CS2. Because this is moles over moles, this is a mole ratio. And where I'm getting the numbers to go in these spots is just my balanced chemical reaction. So going back to my balanced chemical reaction, I have 2 moles of CS2 for every 4 moles of H2. The unit of moles of CO2 will cancel out. Everything on top, hit divide. Everything on the bottom, hit equals. And I get a total of 5.94 moles of whatever's left, moles of H2. Now this makes logical sense in my opinion. The ratio is saying I need twice as much H2 than CS2, and 5.94 is roughly, and actually is, twice as big as 2.97. That makes logical sense. So what I'd like you to do at this time is pause the video and give D a try. Pause the video now. Now that you've had a chance to try the question, let's go through it together. So the goal of the question is to calculate the number of moles of CS2 required to react with 17.2 moles of H2. Well, I have to start with the number I'm given, which is 17.2 moles of H2. I then write a fraction. Whatever I'm solving for needs to go on the top of the next fraction. Well, I'm solving for moles of CS2. And I need to cancel out moles of H2. This is a mole ratio. And the numbers that go in here are the coefficients on the balanced chemical reaction. So I look at CS2, it's 1. And I look at H2, it's 4. So moles of H2 will cancel. I put everything on top in one set of brackets. I hit divide. I put everything on the bottom in one set of brackets. I hit equals. And I get an answer of 4.3 moles of CS2. Now this seems to make sense. I need 1/4 the amount of CS2 compared to H2. 4.3 moles of CS2 just mentally looks about roughly 1/4 of 17.2. This makes logical sense. What we've done in the last 3 questions is the simplest type of stoichiometry that only requires one fraction and one step. And I know that these questions only require one step because I start with moles of something, I'm going to call it 1, and they want me to figure out moles of something else, I'm going to call it 2. So whenever you start with moles, and they're asking for moles, it requires one step. I have to convert the moles of whatever substance 1 is into substance number 2. So I just use one fraction. And what ends up happening is the moles of 1 cancels out with the moles of 1, and I'm left with the moles of 2. There's some value associated with that based on the numbers in there. So when I read a stoichiometric question and I'm given moles and I'm asked for moles, it is a one-step, one fraction question. What we're about to do is to add another step. Generally in these questions, we are either starting with grams and ending with moles, or starting with moles and ending with grams. This requires an additional fraction and requires an additional step. So I'm going to do one with you, and then I'll give you a try on your own question. So here's our question. How many moles of CH4 are produced when you start with 9 grams of H2? Okay, I have to start with the number I'm given, which is 9 grams of H2. Now here's the issue. I cannot put moles over on the bottom here because I have to cancel out grams. And I cannot compare two substances through grams. I have to compare them through moles. And the reason for that is they have different molar masses. 5 grams of one substance isn't equal to 5 grams of another substance unless they just happen to have the exact same molar mass. So the only way I can do a mole ratio is to first get the moles of the substance I have. In this case, that would be H2. So I have to convert grams into moles using molar mass. Now, hydrogen has a mass of 1.01 grams for every mole, but if it's H2, then I need to multiply that by 2 to get the molar mass of the molecule, which is now 2.02 grams for every 1 mole, because the unit of grams per mole is a fraction. And so that's what I'm going to do in this spot here. I first need to get moles of hydrogen, so I'm going to put that on top. But the only way I can do that is to get rid of grams of hydrogen. That needs to go on the bottom. Now, grams over moles, or in this case, moles over grams, is simply a molar mass. Now, in this case, the molar mass has been inverted or taken to the power of -1. So rather than 2.02 grams over 1 mole, this is for every 1 mole, it weighs 2.02 grams. All I've done is taken this fraction and raised it to the power of -1 in order to get the unit of gram on the bottom of the next fraction so that that unit will cancel out, which we're going to do right now. The grams of H2 cancels with the grams of H2, and now I'm left with moles of H2, which allows me to now do a mole-to-mole ratio. This is my first step, and I wouldn't punch this in my calculator. I would just leave it as is, and then I would set up my mole ratio. So now, my goal is to get moles of CH4. What I need to get rid of is moles of H2. I look up their coefficients. H2 is a 4. CH4 is a 1. The unit of the mole of H2 would cancel with the unit of the mole of H2. This would end up leaving me with a mole of CH4, which is the goal of the question, to get moles of CH4. How do I put this in my calculator? Open bracket, everything on the numerator, close bracket, hit divide. Everything on the bottom, close bracket, hit equals. This would be step number 2. And the answer would come out to 1.1 with rounding moles of CH4. Now, if you were to use an equation for any part of this reaction calculation, this part here would be moles is equal to mass times molar mass. But this here, step number 2, is a mole ratio and cannot be done in any other way. It has to be done as a fraction, canceling out the units. My suggestion, though, is to always use fractions if you plan on continuing to take chemistry at a higher level, because it becomes more complicated and nobody will be using equations like this anymore. Let's try a question on our own. The question says, how many moles of H2S gas are produced when 66 grams of CS2 gas completely reacts? I again am starting with moles, or asked for moles, and I'm starting with grams. I will have to convert CS2 into moles first before doing a mole-to-mole ratio. Pause the video now and give F a try. Now that you've had a chance to give it a try, let's go through the answer. So, starting with the number we're given, 66.0 grams of CS2, we must make a conversion to moles of CS2 because that is the only way we can compare two different compounds in a reaction, is through moles. Grams is no good to me unless I convert it to moles. So, to do that, I would have to calculate the molar mass of CS2, which happens to be 76.24 grams of CS2 for every 1 mole of CS2. What that will do is cancel out the grams of CS2, and I'm left with moles of CS2. This is my first step. Now that I have moles of CS2, I could do a mole-to-mole ratio using the coefficients in the balanced chemical reaction. Now, whatever I'm solving for needs to go on top, which would be moles of H2S, and whatever I'm getting rid of needs to go on the bottom, which would be moles of CS2. The coefficient on H2S is 2. The coefficient on CS2 is 1. This here is my mole ratio. and the unit of moles of CS2 will cancel with moles of CS2. Everything goes on top in one bracket. You hit divide. Everything on the bottom goes on one bracket. Then you hit equals. And I get 1.73 moles of H2S. So, in summary, if I'm starting with grams of substance 1, I'm going to need 2 fractions in order to get moles of substance number 2. I would then have to convert grams of substance 1 into moles of substance 1 by inverting the molar mass of that substance. This here is a molar mass, and the number of moles here is always 1 because molar masses are always grams per 1 mole, or in this case, for every 1 mole, you have a certain number of grams. This will cancel the grams of compound 1 with the grams of compound 1. You now have moles of 1. In order to convert the moles of substance 1 into substance 2, I have to do a mole-to-mole ratio with the moles of substance 1 on the bottom and the moles of the substance 2, the one I'm solving for, on top. This will cancel out the moles of substance number 1 and leave you with an answer in moles of substance number 2. This is accomplished through a mole ratio, where the moles in this spot, here and here, are from coefficients in a balanced chemical reaction. In our next question, we are going to go the opposite direction, which is, rather than starting with grams and ending with moles, we are going to start with moles and we are going to end with grams. So let's read the question. How many grams of CH4 are produced when 9.3 moles of H2 completely react? So, as usual, we have to start with the number which we are given. In this case, it would be 9.3 moles of H2. Now, a common mistake, just because we have been working with molar masses so far, would be to figure out the molar mass of H2 and convert it to grams. But that's ridiculous. We always want to do a mole-to-mole ratio. So if I'm given the number of moles to start with, I can go straight into a mole-to-mole ratio. I repeat, if I am given moles to start, I do not need to do a conversion to start. I have moles. I can immediately go into a mole-to-mole ratio. So, I need to figure out grams of CH4, but first to do that, I would have to have the moles of CH4. I can figure this out by doing a mole-to-mole ratio of what I've started with, which would be hydrogen. Now, the coefficient for H2 is 4, and the coefficient for CH4 is 1. So in my first step here, what I've done is a mole ratio, not a conversion to grams, because I can't use grams to compare two substances. The moles of H2 will cancel out with moles of H2, and now I have moles of CH4. This is my first step. Now the question ultimately is asking to get grams of CH4. So I need grams of CH4 on top, but I need to cancel out moles of CH4, so that has to go on the bottom. Now what unit has grams and moles in it? A molar mass. In this case though, the moles is on the bottom, and in a molar mass, the moles is always 1. And the molar mass for CH4 is 16.05 grams for every 1 mole. This would be my second step, and it would convert moles of CH4 into grams of CH4. The moles on top cancels with the moles on the bottom. I put everything in the numerator in one set of brackets. I hit divide. I put everything on the bottom in one set of brackets, and I hit equals. And I get an answer of 37.31625 grams, but with significant digits, it's only 2, and I will leave it as 37 grams of CH4. In our next question, we are going to take it a step further. We are going to be starting with grams of a substance and ending with grams of a substance. This would require 2 conversions to moles plus the mole to mole ratio, and we are now up to 3 fractions. So, as a quick review, when I have moles and moles, it only requires 1 fraction. When I have grams converting to moles, it requires 2 fractions. And now in this harder one, we are going to be going from grams to grams, which will require 3 fractions. Let's start with the number we're given and work our way through. So starting with 6.3 grams of CS2, I recognize that I need to convert this to moles. I would do this using a molar mass. So how many grams of CS2 are in 1 mole of CS2 would be its molar mass. The molar mass of CS2 is 76.24 grams. The grams on top cancel with the grams on the bottom, and in my first step, I've converted CS2 into moles. Now that I have moles of CS2, I can convert this to moles of H2 in another fraction doing a mole ratio. So I'm going to put moles of what I want to get rid of on the bottom, moles of CS2, moles of what I want to get on top, moles of H2, and then I'm going to insert their coefficients. So CS2 is 1 and H2 is 4. The moles of CS2 will cancel and I'm left with moles of H2. Step number 2 is my mole ratio. Now the question is asking for grams of H2, so I need to do one more step and convert moles into grams. And what unit has moles and grams is molar mass. I want to cancel out moles, that goes on the bottom of this fraction, and what I want to get is grams, so it goes on the top of the fraction. There is 2.02 grams of H2 for every 1 mole of H2. The moles on top cancels with the moles on the bottom. This is my third step. I put everything on top in one set of brackets, I hit divide. I put everything on the bottom in one set of brackets and I hit equals. And I get an answer of 0.67 grams of H2. I would now like you to try letter I. Please pause the video and give this one a go. Okay, now that you've had a chance to try the question, let's go through it together. So the question is asking how many grams of CS2 are required to make 200 grams of H2S. So starting with the number we're given, 200 grams of H2S, I know I must convert that to moles of H2S because I need to do a mole to mole ratio. I must then get rid of the grams of H2S that goes on the bottom. Now, grams and moles is molar mass, so the number of moles is always 1 here. And the molar mass of H2S is 34.09 grams. This cancels out grams of H2S on top with grams of H2S on the bottom, and I'm left with moles of H2S. This would be my first step. I then have to convert moles of H2S to moles of CS2. Whatever I want to get rid of goes on the bottom, moles of H2S. Whatever I want to solve for goes on top, moles of CS2. I look up the coefficients. CS2 is 1, H2S is 2. This is my mole to mole ratio and is my second step. The moles of H2S cancels with the moles of H2S. Now in my last step, I need to get grams of CS2, so I must put that on the top of my next fraction. I want to get rid of moles of CS2, I put that on the bottom. Grams in moles is molar mass. For every 1 mole of CS2, it weighs 76.15 grams. This is my third step. Moles of CS2 cancels with moles of CS2. Everything on top in one set of brackets, hit divide. Everything on the bottom in one set of brackets and hit equals. And I got 223.379 grams of CS2. With significant digits, it would be 223 grams of CS2. So to review the last two styles of mass stoichiometry, I'm going to do it in this space below. In review, to how to turn moles into grams, we would need 2 fractions. I would start with the moles of substance number 1, and I would convert that into the moles of substance number 2. I would do this using a mole fraction. The moles of 1 would cancel with moles of 1. I would then have to convert the moles of 2 into grams of 2 using the molar mass. This would cancel out moles of 2, everything on top, hit divide, everything on bottom, hit equals, and we would get grams of the substance we're solving for. The fourth type we did was converting grams of 1 to grams of 2. This requires 3 fractions. We would start with the grams of the first substance and turn that into moles of the first substance using the molar mass. Moles of 1 on top, grams of 1 on the bottom. This is the molar mass. This mole here is always 1 because it is a molar mass. Just like here, this was always 1. So grams of 1 will cancel with grams of 1. Then I need to do a mole to mole ratio, so I can convert moles of 1 to moles of 2 using a mole to mole ratio. This will cancel out moles of what I started with. And then in my last fraction, I will convert moles of 2 into grams of 2, canceling out the unit of moles of 2. Everything on top divided by everything on the bottom, and you'll get your answer in grams of 2. I hope you have enjoyed this lesson of You Got Hope Chemistry. See you next time.